Hey everybody, Jem Schofield here, and welcome to the Canon Cinema EOS C200 and C200B video training series. I am here with Loren, and Loren, we are in the edit suite here at Canon's Burbank facility. What's the purpose of this suite?
Yeah, so the whole idea behind the entire Burbank facility is post-production and production integration. We want to show filmmakers how our products fit into their workflows, both on set and in the DI suite. So we want to actually be able to show if you're a Mac editor or a Windows editor through Adobe, Final Cut, DaVinci, anything you want, anything that you work in, we want to be able to show how we can integrate into that very easily. So that's what this whole room's all about.
That's great. So in this video, we're going to be talking about Cinema Raw Lite. Talk about Canon's Cinema Raw development software and a couple of other post-production solutions.
Yeah.
So let's get started. So the first question that I have for Loren is, what exactly is Cinema Raw Lite?
Yeah, so Cinema Raw Lite is the newest RAW format from Canon, and what's really important that it is a RAW format. It is Bayer pattern sensor information that needs to be de-Bayered in software like Cinema Raw Development or DaVinci Resolve or even Avid with our plugin. So it's something that needs to actually be processed to visually be seen.
And that means we're taking something that is raw, which is just a signal coming off of the sensor, and we are converting it into a video signal.
Yep, and we're going to check this out actually in the Cinema Raw development itself.
Great, so let's bring up some stuff that was shot in Cinema Raw Lite, and if you can just give us just a tiny tour of what this software is all about and what it's capable of, that would be great.
Totally. So here we are. We're right now in a dual screen configuration, but these are all just independent little windows that we could drag and make whatever size we want. Here's basically our library. This is just our whole SAN server we've got here. So what you'd want to do is navigate to your reel from your at this point, C200. You'd be looking at .crm files. And basically, every file in here will actually show up a little video preview. And you can actually, right now, I'm sending it out over SDI. So I'm going to just turn that off for a moment so I can see this preview right here on the screen.
Okay.
And I can do things like change my white balance. So I can just dial in a color temperature. You know, this was outdoors, so something in that 5600 Kelvin range would be accurate. I've got brightness adjustments here. I can do some white balance little shifts here, but really what's the most important here is these preview settings. How you want to see the Cinema Raw Lite footage actually de-Bayered. So we can go as large or as small as we want. The largest sort of biggest bucket to start with would be our debayering into Cinema Gamut and Canon Log 2. This is going to be the flattest image, and it's going to basically be the best starting point for a very heavy color correction. But if you want to just quickly see some previews of this, I could say, you know what? I'm on a 709 display, so make this a 709 image. And Gamma, I want to go sort of more linearized, wide DR. And then boom, we're set there. And this actually was shot a little overexposed. So if I just reset this back to 0, you can see.
That's how it was shot.
This is how it was shot. And I just decided that it was about a stop and a third under, or over that is. So I'll just take it a stop and a third under. And we can bring that in and actually get more detail back in those clouds. This shot was actually about 2 stops over. So this stuff is pretty gone out. And then I'll take it down 2 stops and really get a lot of that detail back in the clouds. Because again, we're just looking at a wide DR transform of this, not the actual sort of Canon Log 2 biggest, flattest starting point.
Okay, good. So let's go ahead and change that color space back to our Cinema Gamut and to, let's say, Canon Log 2, which would make a lot of sense if you're shooting a scene like this.
Yes.
And we can see that we are looking into those highlights there. But what you're saying is that when we then get into the place where we're taking this and we're putting it into the targeted color space and the targeted gamma, then we can really see what happens when we're essentially putting LUT onto our footage. So let's now go ahead and change that back again to our wide DR, and we'll just go ahead and go to our BT709 for our color space. And we can see that it is well overexposed. And then when you made that adjustment, we can still get back that information because it was all in there in that Cinema Raw Light file.
Exactly.
Okay, good. This makes a lot of sense. You also had that SDI out on before. What are we pushing our image to right now? Because we are obviously dealing with HDR footage in its native format. So what are we looking at that on right now?
Yeah, so we're sending this out actually through a Blackmagic Ultra Studio 4K Extreme into the Canon DP-V2420 1000-nit HDR reference display.
Okay, so much brighter than an SDR display.
Yep.
Much greater contrast ratio, and much wider color space than 709.
Correct, yeah.
So what we're looking at right now on the monitor is our BT709 in terms of color space, and you're pushing out a YDR gamma?
Yeah.
So why YDR as opposed to 709?
So 709, the actual BT709 gamma curve is very linear, so it doesn't really handle highlights as well as something like YDR. So here's the standard BT709 curve.
Wow.
It's just not designed to have that sort of roll off like a YDR does. YDR literally in the highs just starts to roll that detail off a lot sooner and a lot smoother.
Actually, a lot of people like to shoot with YDR in their Cinema EOS cameras, and how is it in the C200?
Yeah, so a lot of people don't even realize, but when you go to the preset BT709 under your custom picture setting, that is actually the YDR gamma curve. It's not just the standard BT709 gamma curve.
But that does fall within BT709.
Yeah, it's designed to look good on a BT709 display, but it again has that very nice slight highlight roll-off.
Got it. Now, if you change your color space to, let's say, DCI P3, and also your gamma to DCI, and we were targeting that, would we have to make any changes on this monitor at all?
Yes, you would, because you're now showing a wider color space, and the beauty of a reference display is basically you want to tell it what signal it's going to be receiving so that it can map that to its primaries.
Got it.
So all I'm going to do here is jump into the menu, go to the picture mode and say, hey, you're no longer receiving a 709 signal, you're receiving a DCI P3 signal.
Got it.
And now that's going to map it, and DCI-P3 is a projection standard, so you'll see it gets a little dimmer because it's designed for a 48-nit projection.
Got it.
But this is now a proper showing of DCI-P3.
Got it. You have to match your signal to your reference display.
Yes.
And that's going to be important not only in post-production, but in the longer term in production. When we start to work with these wider color gamuts and these different gamma curves. So we're going to have to think about that on set as well.
Oh yeah, people are going to have to become a lot more aware of color gamuts and what color gamuts and color spaces are on set.
And I'm imagining that as we go forward, when we're starting to see more of what our cameras are actually capturing, it's also going to change the way we work with color and also the way we light.
Yep.
So that's going to be pretty interesting.
It's a brave new world.
Okay, good. So let's get back to Cinema Raw development. And let's talk about some of the things that that's capable of.
Yeah, so I'll actually take us back to some of the stuff you shot earlier, and we'll actually head down and go to our lovely model, Christy.
Okay.
And I'm going to reset all of my settings here, just kind of go back to my shooting setting defaults. And then I'm going to take my image and bring it out of my SDI and back into my my computer.
Just so we can see it.
Yeah, exactly. Okay. So we're back here to sort of a more standard, what you might see on like a laptop setup or just a standard computer setup.
Got it.
So one of the really cool things about Cinema Raw development is that we've got a huge amount of metadata here. So I'm going to move over to the left screen over here. So obviously we can see we were shooting DCI 4K, 24 frames per second, 12-bit, which is always my favorite part of the camera.
Yep.
But what's really important here, and this is something that you guys talked about earlier, are these color spacing gammas. We're shooting again in raw gamut and raw gamma. And this is really going to come into play when we look at our export settings, because the export works in the sense of it says, hey, if you were shooting raw gamut, where do you want to go to? And if you were shooting raw gamma, where do you want to transcode to? So these are really important things, and we'll come back to this when we get to the exports. So then, at the bottom, we've got our model name, firmware, and even the lens that we were actually using.
Okay.
But over here next to it, we've got our frame information. And this is stuff, sort of your shooting settings, what focal length you were at, your shutter speed, your white balance, if there are any NDs in, ISO, all that good stuff is all recorded right in there. So you can really, I use this a lot for testing. When I'm testing and I want to see, what exposure value was I at here? So that's a lot of really good information in there.
Cool. Okay, so now we've looked at all that metadata. Let's go back to the clip with Christy.
Yeah.
Okay, so right now we're looking at that Cinema Raw Light footage, but we're applying a 709 color space and a YDR gamma.
Correct.
when we were shooting the footage, we were using a LUT, which was a Canon Log 3 LUT, so we could get an idea of what that was. And then our color space for our preview actually was 709. So effectively, this is what we were looking at in our image, right?
Yeah, this is essentially what you were seeing on your monitors, on your video taps, on your LCD. This is what you were seeing. Canon Log 3 709.
Makes sense. So if we then wanted to take a look at this on this other monitor over here, we could just push that. Do we have to also change any settings now that we're using Canon Log 3 as our gamma?
No, because we're sending it 709 and the reference display is set up for 709 still, so.
And it's okay with the Canon Log 3 gamma?
Yep.
Okay, so now we're looking at the image on this monitor. And this was the footage that we shot where we were talking about how to expose correctly with the waveform monitor for log. I'd love for you to talk more about the whole Canon Log 2, Canon Log 3 thing.
Yeah, so what I really want to stress is the idea that if you expose properly for Canon Log 3, you're also exposing properly for Canon Log 2 if you were to debayer into that. So the way we're going to show that is by jumping into F4 here, seeing our waveform. So we can see here that middle gray is landing at 34.3%, just like you guys meant to expose for. And because, again, we're looking at Canon Log 3 on this display, that's all proper. This is what we would expect to see. Now, when I change the debayer to say, hey, let's go to Canon Log 2 instead, we'll see that that middle gray is elevated to 39.8.
Okay, good. So what I'm seeing here with this demonstration is that we just have tremendous creative control when we get into post with Cinema Raw Light.
Yeah.
And if we are exposing correctly for Canon Log 3, then if we decide that we want to work with a Canon Log 2 gamma, that we can do that. And it will automatically do the math for us as long as we're exposing correctly.
Exactly.
And it also looks to me like we're seeing into the shadows a little bit more in Canon Log 2.
Yeah, definitely.
Okay, good. So if we do that, we might just need to know that we're going to spend a little bit more time in the post process. And in Canon Log 3, for a lot of people, that's going to be the right workflow.
Yeah, so Canon Log 2 is definitely the most aggressive curve we make. So it's going to show us the most information out of all the log curves.
Got it.
And with that comes more shadow information, but also more shadow noise.
Right.
But the reason I like Canon Log 2 is because it's that most aggressive curve, we can always dumb it down. So what I'm going to show you in post is that Canon has actually made a 1D LUT that will transform a Canon Log 2 image into Canon Log 3. So we can sort of start with this master media of Canon Log 2 with all the information we want, and then immediately go to Log 3, but then if we need to, just kind of jump back into Log 2 for a couple shots if we need to for the entire project.
That's pretty cool. Okay, good. So that means that now that we've talked about all this stuff, we need to get files out of here.
Exactly.
So let's talk about getting files out of the Cinema Raw development software.
Yeah. So I'm going to turn off the SDI out just so we're all on the computer screen. Jump up to File, and then Export Configurations. And the first thing we're going to see here is just naming conventions, keeping the same file name as the RAW, directing where we want to send it to, if we want to also copy the RAW files, proxy files, and these full quality files. So to define the full quality files and the proxy files, we're going to go up here to first full quality files. So first things up here, we can use quick development. This will do different algorithms that are faster, but not as optimized for quality. So if I was just trying to do something quick for just a quick daily, maybe I would use quick development. But for making masters, I wouldn't really use quick development. So under our file type, we can choose either our 10 or 16-bit DPX. We can choose ProRes Quad 4. Or we can choose OpenEXR for ACES. And if we choose our OpenEXR, we actually can do our IDT right here. We can set it for auto select, and it will choose either daylight or tungsten based on the metadata. So now this OpenEXR file will actually be already encoded into an ACES space and ready to be worked in any standard ACES environment.
Okay.
So you see that all of our color space and gamma options are grayed out, and that's because we're going to an ACES space. So I'm just going to go up and go to something like ProRes, and now we can define what color space and what gamma we're going to debayer into. Again, the preview settings over here have no effect on what our actual export is going to be. This is where we're going to be setting that stuff up.
Okay, but what about your other settings above that?
Exactly. So these settings will actually apply. So if you change your white balance, if you adjust your brightness or your sharpness, that will actually apply for when you're exporting. So looking at our export, for the C200 specifically, the only row we're going to look at is this one, raw gamuts. Because again, remember in that metadata, we saw that we were shooting in raw gamuts. These other spaces are for the C300 Mark II or the C500, but for the C200, this is the only row you want to look at.
Got it.
So like I talked about before, I always want to start with the biggest bucket. So I'm going to choose Cinema Gamut for my color space because it's the widest color space, and then Canon Log 2 for the gamma because it's the most aggressive gamma. So that's going to be for our master media. We can also do some D-squeeze if we're going to shoot anamorphic, but that's more of a specialized environment.
So what about output type proxy clips?
Yeah, so we can also output proxy clips simultaneously or independently, actually. So here I would use quick development because we're not super critical here. I would choose a file type, probably just a ProRes LT, and then I can either match the actual gamma and color space settings of my full quality clips, or we can actually do this independently and say, you know what, I want these offline edits to be basically 709 and something like YDR, so that the editor is dealing with a LUTed 1920 image instead of having to deal with a very flat picture.
That makes sense.
Yeah.
Good. So when you go to OK now, is it automatically going to start to create those files?
Once I drag some clips into the actual export queue. So I've got to basically say, hey, I want this clip to be exported.
Got it.
I can actually quickly set ins and outs. So I could just go to something around here, hit I, drag to here, hit O,
Yep.
and then just simply drag this down, and it will take that in and out point and put that here. And then I just begin the export, and it'll start exporting it.
Great. So that is the Canon Cinema Raw development overview and how to work with the software.
Yep.
Let's go ahead and jump into DaVinci Resolve and see what happens in that application.
Yeah.
Great. So now we are in DaVinci Resolve.
Yeah.
Let's talk about working with these Cinema Raw Lite files.
So it's really simple in DaVinci Resolve because they can actually debayer our RAW natively.
Okay.
So I've imported some clips already, and we can already see that this is a .crm file that's actually being debayered live. I can play, it's smooth, I get full 24 frames per second playback. And you might be asking, well, it's raw, so what am I seeing here? Obviously, I'm not seeing raw. What log, what gamut has it gone to? There currently in this version of DaVinci, there isn't the capability to change our Canon Log 2 or Canon Log 3 or Cinema Gamut or 709 debayer itself. So by default, it comes in as Cinema Gamut Canon Log 2, which might sound familiar because that was what I recommended.
Yeah.
It's basically the widest of everything. It's going to give you sort of the best of everything, and you can always dumb down from there. Which
so this is a great starting point.
Exactly. It's a great starting point, and I'm going to show you how to get this image to look exactly like we would see it on the C200 on the screen, or how we could go to sort of a final finished image as well.
So if we wanted to take this Cinema Gamut Canon Log 2 image, and we wanted to see this in Canon Log 3 with a YDR or BT709 color space.
Yeah.
Can we do that?
Yeah, we can.
Okay.
So let's do that right now. So I'm going to jump into Edit. I'm going to grab this 2x clip here, drop it in the timeline, pick a flattering frame of everyone, and then simply jump into the color already.
So you had spoken about in the previous segment being able to very easily get from Canon Log 2 to Canon Log 3.
Yep.
So how would we do that in DaVinci Resolve?
It's super easy. So Canon has a LUT pack available for download on their website.
Okay.
It includes both 3D and 1D LUTs. So all we need to do for a gamma transform is use a 1D LUT. So I'm just going to head over to the LUTs in the DaVinci Resolve, go to Canon, go to Gamma, which is essentially a 1D LUT, Canon Log 2, because we were looking at Canon Log 2 footage.
Okay, so it is a little confusing because you go into 3D LUTs.
Yes.
But then you go into Canon and there are both 3D and 1D LUTs.
Correct. So I could divide this up in the architecture of the LUT folder, but basically I've got a folder that is the Canon produced LUTs.
Okay, got it. Okay, that's the way you have actually structured it.
Exactly.
Okay, got it. Okay.
So I'm going to go to Canon Log 2. I want to go to the 12 section because we're working in 12 bits.
Yep.
And then Canon Log 2, 12 to Canon Log 3. And I click this, And we're now in Canon Log 3.
Okay, so Canon Log 3, but still in Cinema Gamut.
But still in Cinema Gamut, correct.
Okay, so now let's talk about LUTs a little bit more.
Yeah.
There's a little bit of confusion out there because we have these cube LUTs, and we see numbers like 17, 33, 65.
Yeah.
What is the difference between those?
Yeah, so it's the complexity of the math.
Okay.
So, 17 by 17 LUTs, those are minimal processing. Usually that's what you might see in like an onboard monitor or something like that. They're not as accurate because there's less math involved, but they're less processor intensive.
Okay.
33 and 65 are really what you'd want to be using in a post-production environment. I tend to just use 33s. On a really powerful system, you can use 65s, but there's diminishing returns at that point.
Okay.
33 is pretty much where I live. I would not use the 17s though in a finishing environment.
Okay, great.
Yeah.
Good. So what if we now want to take something and we want to target it a little more specifically, where we are going to take a gamma curve and we're going to take a color space that is going to be for delivery?
Yeah.
So what would we do with that?
Yeah, so I'm just going to reset this node graph here.
Yeah.
And I'm going to go back to my 3D LUTs.
Yeah.
And instead of going to just the gamma section, I'm going to go to the actual 3D LUTs section.
Okay.
So we're in Cinema Gamut now, so I've got to choose one of these options.
Yep.
We're in Canon Log 2, so I've got to choose one of these options.
Got it.
And now I have to decide, where is this going to go? Is this going to go to a 2020 display? Is this going to go to a PQ display for HDR?
Okay.
For the most part, right now, most things are going to a 709 display, so you want to go to a 709 gamut and a wide DR gamma curve. So I'm going to click this, and that's going to be a proper 709 wide DR curve image. So this is essentially what you would see in camera if you were in preset BT709.
Okay, and then we can go in and we can tweak that LUT if we need to.
Yes, you can go in before the graph and just actually start lifting things and do it non-destructively.
Okay, good. Great.
Yeah.
So that's a basic DaVinci Resolve, very basic DaVinci Resolve workflow.
Yeah.
But the thing that's great about this application is it is available to anybody at no cost.
Yeah, it's amazing how much it used to cost compared to being free now.
And on a Mac or a PC.
Yeah, the one thing I will note with the free one is that it limits you to Ultra HD, so you don't get DCI support, the 4K 4096.
Okay.
So it's fine because for the most part you'll probably be delivering in Ultra HD, not DCI. You just want to set up in your preferences that you probably don't want it letterboxed, you probably want to crop instead, but it's a preference thing.
Okay, good. Yeah, because DCI 4K is 17 by 9, and obviously UHD is 16 by 9.
Exactly.
Okay, perfect. Good. So let's jump into Avid and take a look at that plugin.
Yeah, totally.
So Loren, now we're in Avid Media Composer.
Yep.
And tell us how we can get to the Cinema Raw Light files in this.
Yeah, so the integration is super simple. All you do is you go to the Canon website, the same place you downloaded the LUTs, you'd actually just download the plugin. So you download the plugin, install it, and then through your source browser, you just simply navigate to your footage like you would any other footage.
Okay.
And so I'm just going to go to my real one here. And then you can just click the CRM folder in the structure.
Okay, so those are our Cinema Raw movies.
Exactly, yep.
Okay.
And you don't even have to click into it. You can just click that folder, simply click link, and then it will populate up here in the bin. We've got the file name, obviously. We've got the camera it was shot on, the gamma, and the color space. But you might be saying, hey, this was raw. We don't have Canon Log 2 or Cinema Gamut by default. So the plugin is actually by default debayering into Canon Log 2 and Cinema Gamut.
Just like Resolve.
Just like Resolve.
Right.
You're noticing a common theme here. Everyone's choosing the biggest, the baddest, the most information to start with, which makes the most sense.
Absolutely. And so can we then just start working with the clips?
Yeah, totally. You can open them up just like any other clips in Avid and play, and it's smooth, and it's a really simple integration.
Okay, great. So then whoever's using Media Composer can go in there. They can start to work with the files. They can start to edit those files and do what they're going to do.
Yeah, totally.
Great. So I think you prepared some of these clips in the OpenEXR format.
Yep, exactly.
So I'm going to go over to the DI suite, talk to Nico about that.
Yeah.
And thanks so much.
Yeah, no problem.
Great. All right. I'm now in the DI suite with Nico. How are you?
Hi, how are you doing?
I'm doing well. So we're going to talk a little bit about higher end post workflows with this footage off of the C200. But before we do that, Nico, if you could tell me just a little bit about yourself and also what the purpose of the DI suite is.
Well, my name is Nicholas Recano, or Nico. Everyone knows me as Nico. I'm a colorist product specialist and a consulting engineer for SGO Mistika here in the US. I'm working very closely with Armadillo, who is a systems integrator and value-added reseller in the area. I am collaborating very closely with Canon, who has set up a fully spec'd Mistika DI system, Mistika Ultima. And we're currently in the DI room, which is a technical playground where we can work with all the different raw camera footage coming from all the different cameras. For all intents and purposes, this is a place for doing proper color grading work, as well as it's also a place to experiment and try things out. It's we've got the high bandwidth storage, and we have a full SAN infrastructure. And we've also got a supporting edit suite in the Burbank office with software running on both Mac and PC. And we've got a fully spec'd DCI compliant projection system based on a Barco 4K. And we also have access to fantastic HDR-capable displays from Canon, both the 24-inch and the 30-inch. And the Mistika is feeding straight to the projector.
Great. What I'd like you to do, Nico, now is maybe take us over to the Mistika and tell us a little bit more about OpenEXR and ACES by using the clips that you have.
Okay, perfect.
Okay, let's do that.
So we've just, Loren was kind enough to convert the raw camera footage into an ACES space, which means that it is scene linear, and it's a direct encoding of the original scene in digital format. What's interesting is we're encoding it into a EXR file or OpenEXR file, and the EXR file is known to be a floating point file, image file. What does it mean, floating point? Whilst in a normal, say, DPX, ProRes, or movie file, we usually have an encoding that goes from 1 to 100% video levels. Whilst in floating point, we have 0 to 1, but we actually also capture all the values below 0, and all the values above 1.
Can you show that to me?
So if we actually go in, and we can actually see here in the waveform monitor how we can see values that go well above here in floating point space.
Got it.
Up to 12 in code value terms.
Okay.
And 5 here in green and so forth. And we can then see also measure in black, and we can see that there is some flicker of values into negative.
Okay.
So all of that digital signal to noise in the blacks are also preserved. So we've literally got the raw sensor data from the camera.
Okay, and so when we're looking at it this way, it may not look like it looked to us when we were on set.
Correct.
Or when I was working with Loren in other applications.
Yes.
But all of the data's there.
Correct, yes. So this has been linearized. So all of the display bias, all of the encoding, all of the aesthetic contrast that might be applied, the wide dynamic range, lookup tables and so forth that actually make the picture look good, have been completely removed, and we've got the raw footage.
Awesome.
And here we're seeing it as extremely contrasted, because the only thing that we see in this GUI is the values between 0 and 1012. So all the stuff that's below or above has been clamped off, which would obviously not be what we want to work with.
How can we see that other stuff?
So, well, this is what we do. And we now need to move into a grading space, something which we can work with within the 0 to 1 range.
Okay.
And in most cases, we want to encode into a log space, which is a way of squeezing all that scene linear signal into a comfortable range where we can, wiggle the dynamic range of the picture in the color grading process. So here we can apply like a unicolor node, which simply converts to ACES CC.
Okay.
And we can then also apply a display filter, which is like a viewing LUT that applies an ACES CC to P3 DCI. And we can activate it.
Is that what we're looking at right now is DCI?
Correct. So this is a Barco 4K DCI compliant projector. So this is literally what you would find in the most high-end suites for digital color timing, color grading.
Awesome. So this looks more like what we would expect.
Correct, yes. And then all of this is coming from the absolute rawest of raw sensor capture to a beautifully looking picture where we can start working exposure. I mean, this already is correctly exposed. However, there's a lot of information that we can expose here. So if I actually zoom in and I can see her face, and I can also look at the light bulb. So we say, what dynamic range does this picture have? We can actually lower the exposure, and we can see that there's a little high on the light bulb.
Right.
So none of that signal has ever been clamped in the entire color pipeline.
Got it.
In the digital color pipeline.
Okay.
And so we can expose up, and we can see that there is actually also a high in the blacks.
Right.
So all of that information has been preserved in the entire dynamic range of the picture.
Okay.
So we're definitely dealing with a raw output directly from the C200.
And what about skin tones? You're talking about that.
Yeah, so skin tones are great. The very first thing that we would do in any color grading session is literally white balance the picture. Now, in terms of white balance, we can say that it is slightly warm. If I go in and I can actually sample that, you can see these crosshairs, you can see that there is a little bit more red. So we can actually bias the red and neutralize the white. However, the really interesting aspect as well as working with RAW is that there is no visible compression artifact. So if I was to work like in a key, I will just create another layer here and work within a key, I can immediately do a luminance key, and I can see that we've got all the graduations without any
her skin tone.
Correct.
Yeah.
So we actually have no posterization. We've got all of the luminance steps to basically pick up all the details, all the minute details of the skin,
Yep.
the texture of the skin. Furthermore, as a commercial colorist, you would want to very much work like in the red channel. The skin tones is fundamental to try and make, skin tones aesthetically pleasing. So I can further qualify and simply say, I just want to work in the red channel. So immediately there, we've got a very, very nice key of just her face, right?
Yeah.
And very popular things that you can do is you can just contrast, say, for example, her skin tones, make her more stern, strict, edgy, or we can just make her more L'Oreal, glowy,
Yeah.
and more aesthetically pleasing.
And that's because that information is in there. That's what's giving you that capability to do that.
Yeah, the fact that we're working in RAW, the fact that there is no compression artifacts, and that we've got the entire dynamic range, all the sampling of the luminance of in the picture is there. So we never see any banding. Furthermore, if I should even go in and do something even more drastic, like lift it up, although I'm lifting the image, I am not actually noticing any fizzing in the picture.
Yeah.
It's a very solid key.
Very cool.
So the other thing, which is just as a color grading trip, is we would always try and defocus the alpha very much in order to hide the fizz in, like, the noise in the skin tones.
Right.
But in this case, because we've got such a clean key, we don't actually need to do that. We can actually go and focus on skin tones and make them as pretty and or as edgy as you want without actually falling into the typical pitfalls of too much noise.
Cool. So, Nico, I know that you have another clip here that you're going to show us. So why don't you take us through that?
So here we've got actually a test shot that was shot by Loren, which is shows us a purposely overexposed scenery.
Yep.
And yet, because this is raw, once again, we can actually recover a lot of that dynamic range.
Okay.
It still requires a bit of contrast to be added, of course, and we can, contrast it as necessary. And we can also add some saturation there just to really make it shine.
And what if you wanted to take that a step further? What could you do?
Well, another thing which you can do is, of course, the clouds are particularly bright and it's very nice, but we want to try and enhance the clouds. It's a very aesthetic thing that we can add. We can add things like a window. So here I'm just adding
Got it.
and we can add some fall off.
So that's a little feathering that you're
A
adding
little
there?
feathering, absolutely. And
Okay.
then, of course, here, just going back into primary, we can just lower the exposure immediately there and
Got it.
create a much more balanced shot.
Can I see what the original looked like?
Of course, you can go like this, or we can actually revert right back to the original.
Wow. Okay, so
Picture.
huge difference.
Yeah,
Yeah.
absolutely. And all of this is because we're working, of course, in a beautifully raw space.
Awesome. Okay, Nico. So we've had a look at two drastically different clips. I'm really seeing that there's a tremendous amount that you can do with this footage that's shot in Cinema Raw Light.
That's right. And in turn, the Cinema Raw Light can be easily converted into ACES OpenEXR, which in turn is designed to remove all the camera bias of the different cameras. So we can compare apples to apples in every case. We can compare the C700 with the C200 and with, in fact, the media of other camera manufacturers. And that is obviously very, very useful. And it also makes the life of a colorist much easier because even if you do go into a multi-camera shoot, it is much easier for us to match all the different cameras, the outputs of all the different cameras into a consistent looking picture.
Great. To Nico and to Loren, a big thanks for showing us these post-production workflows with Cinema Raw Light files with the C200 camera series. Thanks for watching.